Okay, start with A first. Assume the number of emails received by a student daily Poisson with mean 5, x number of emails received daily. So for a day, x distributed Poisson mean 5. For the first one, A1, determine the probability the student receive 5 and 13 email dailies, so inclusive. So read your table. Between 5 and 13, so not included. From 5 to 13, included. If say from 5 to 13, yes, included. Ada equal. Between 5 and 13, tak ada equal. But between 5 and 13, inclusive, ada equal. So you have to read the question carefully. Not always between, not equal. And you said between, after that, inclusive. You got the word inclusive? Yes, you got equal. Okay, so this one between, so not equal. And it said inclusive. So to read table, it will be start more than equal. 5 is not included. Start from 6, we read on. Minus 13. 13 also not included here. So Poisson 5. Lambda 5. Read from 6 to 13. 6, 3, 8, 4, 0. 13, 2, 0. And then number 2, if the probability student receive not more than m. Not more than m means less than equal. Daily is, in a day, means still same distribution because this one is also a day. Is 0.616. Determine your m. Means reading we don't have, probability we have. So how we going to read less than equal m in table? We will 1 minus more than equal m plus 1. Alright. So m is included. So the next number after m will be m plus 1, not included. So start from m minus m plus 1, you minus out. Cannot? Cannot. If you cannot, we just assume we put a number. If px less than equal 3, how are we going to read? We will px more than equal 4. So if this one is m, this is m plus 1. Alright? So we simplify this. It will be 0.384. So what reading can give you 384? Poisson 5, what reading? Oh, this one. Probability 384, reading from 6. Means m plus 1 is 6, m is 5. Then we come to part B. If 15 days are randomly chosen, find the probability student receive 5 to 13 email daily for the period of 9 days. So here a bit confused. They want to find sample. Now it's not finding how many emails. Now it's finding how many days. So X originally is represent email in a day. Now they are not asking us to find email, they ask us to find within this 15 days out of 9 days. So sample is 5. So Y now is represent the number of days. In what situation? Receive emails between 5 and 13. So email received 5 and 13, this probability is equals to 0.382, which already found in part A. So Y distributed binomial in sample 15 days, receiving as much as between 5 and 13 email, situation is P 0.32. So finding the probability, the student for the period of 9 days. So find the probability, number of days is equals to 9. So in binomial, we can use formula 15C9, then 0.382 power 9, Q will be 1 minus 0.382, which is 0.618. So figure using your calculator, 0.0483. 0.0483. So when you come to part C, instead of the Y is 15 days, now change to 150. So for part C, sample is 150. Use your normal approximation to find the probability. Situation means still remain the same, receive between 5 and 13 emails. So P still same, 0.382. Y distributed binomial 150, 0.382. So what do you need to find within these days? You want probability less than 70 days. Alright, so look at your situations here. N is large. Then number 2, NP 57 point figure more than 5. So second condition, NP more than 5 fulfill. Number 3, probability in between 0.1 and 0.9 also fulfill. So we change to normal. To get normal, we still need our variance. This is mu. We find out variance, NPQ. $35.41. So X, this is Y. So Y distributed normal, 57.3, 35.41. Then we finding for the probability X, not X, Y, number of day less than 70. So starting from binomial, then change to normal, get to standard form, draw the graph, find from table for the answer. Change to normal, make it decimal, whether 70.5 or 69.5. 70, include or not? No include, means start from 69, which is include less than that. So the boundary can be start from less than that, 69.5. If you take 70.5, then you will include the 70 already. So the CC will be not accurate. Alright, so CC 69.5. Then we change to Z, which minus mean over standard deviation. In two decimal place, 2.05. Then you draw out 2.05 less than that. So for this region, we are going to 1 minus the right tail table, the tail of 0.25. So read up from table 2.05. 2.05 here. This one? Yes. 0202.